All right, good. So this is our second topic, and the title of the topic is known as regression. That is regression analysis. Okay, it's regression analysis. Okay, don't worry about my handwriting. I'm just drawing rather than typing. Okay. All right. So we are going to do what we call regression analysis. Okay. Then, before I can even start, that is the theoretical part. I want to just do some illustration so that maybe we can have a better understanding of this regression analysis. Okay, before now we can go and maybe to the notes. At least we have that is an overview of what is regression analysis. Okay, so regression analysis, we have of course different types of regression analysis. So I can remember two, that is linear regression and logistic regression. Okay, so for linear regression, that's what we are going to cover in our statistics class. Then for logistic regression, you'll majorly cover it, that is under machine learning. It's under machine learning now where you will introduce what we call logistic, that is regression. Okay, for logistic regression, basically, it's an nonlinear regression. Okay, when we talk about linear regression, we are talking about linear from the term linear. It's like a straight thing. Okay, straight line. Okay, so it's something linear. Okay, and we'll also be discussing of different models here. Okay, we'll create a model. In this case, I will create a model which can predict that is the umbrella cells. Okay, I'll now here I will use the other data set, that is the umbrella cells data set. Okay, so I will create that is a model which will be used to predict what? To predict umbrella cells. Okay, yes, that will be our objective. Okay, good. Now, what is an example of a model? Okay, so let me just write something here. Okay, for the statisticians, what is this? If you can remember, what is this? This is for you, team. You can just unmute and let me know what is this. What is this?
It's the general equation of a straight line.
Yes, it is the equation of straight line. Okay, so and remember this as a linear, like between the two variables, that is x and y, there exists what? A linear relationship. Okay, there exists that is a linear relationship. Okay, and I remember this is the equation of straight line back in what? Back in that is in high school, where you were given the xy coordinates. Okay, you are given xy coordinates, and then you were told to plot maybe that is that line. Okay, so once you plotted that line, you could get something straight. Okay, let's assume these were the what? The data points. Okay, let's assume these were the coordinates. Okay, let me just assume that. So let's assume these were the coordinates. Here we have maybe 5, here we have 10, here we have that is 15, and here we have 20. Okay, same as here. Here let's assume we have 2, here we have 4, here we have that is here we have, let's say 6, here we have 8, and here we have what, let's say 10. Okay, and this is an equation of straight line. So what was our that is what was our y, or when in terms of linear regression, what is y, what is m, what is x, what is c? Someone? Wangui?
Sorry. C is the intercept of the line.
Yeah,
M,
which intercept?
intercept of the y-axis.
Yes, that is the y-intercept.
Yeah, the y-intercept.
Mhm.
And then M is the slope of that line.
Yes, m is the slope,
Yeah.
correct. C is the y-intercept. What about x?
X is the independent variable.
Yes, or the predictor
Mhm.
variable. It's
Yes,
the
exactly. Yes.
independent variable or predictor variable. Why? Because it's the one which is used to predict what? Our outcome
Y.
here. Okay. Then what is our y?
The outcome variable or the explained
Yeah, it is
or
the
dependent
explained
variable.
the explained value. Okay, explanatory variable, and also it's also known as dependent variable. Okay, so this is the that is the explained variable, also the dependent variable. Why? Because it depends on the what, on the values of maybe of the other side. Okay, or it depends on x. Okay, then we have m. M it's our slope or our gradient, that gradient of the straight line. Then we have c, it's our what, is our y-intercept. Like for example, if we extrapolate this line, okay, it will cut y-axis at a point, at our certain point. So that point where the what, that is the linear, or that is the regression line. Okay, regression line cuts the y-axis. It is what? It is our y-intercept. Okay, so basically, if I extrapolate this line, you can see the y-intercept is coming to the negative side of what? Of y. Okay, so you expect the value to be what? To be a negative. Okay, then let's come to what? Let's come to m. M now is the slope. Okay, is the slope of the of this regression line. Like for example, we can try to calculate the slope. Okay, and you know that slope is given by change in y divided by change in what? X. Okay, that is the slope. Slope is given by change in y divided by change in x. Okay, so like the distance between these, we can say here it's 10 and here it's 6. So we know the difference is 10 minus 6 divided by, here we have this is 20, this is 10, divide by that is 20 minus what? 20 minus 10. Okay, so in our case, our slope will be what? Our slope will be 4 divided by what? 10, which is 0.4. Okay, then the y, the c intercept, or that is the c constant, or constant c, it's our y intercept. Maybe we can assume this is also 2, 4. Okay, so we can say now, uh, our C is equal to what? Is equal to -2, and that is our M is what? 0.4. So in this case, rewriting this equation or rewriting this model, it will be equal to, okay, that is will be in this form: y is equals to 0.4 x minus what? Because here it's always plus, so it's plus or minus, so it will be minus what? -2. So this is now our what? Our new model, or that is the linear equation. Okay, meaning now if you want to get the value of y given different variable values of x, okay, you can be getting what? The output. All right. Yes, like in example, let's assume we have now the rainfall amount and then we have umbrella cells. Okay, so whatever we are predicting here, we are predicting umbrella cells given change in what? In the rainfall amount. Okay, so in that case, that is, we'll see that, um, like let's assume when we have that is rainfall amount of 80 millimeters. Okay, then that is our cells. Okay, we can predict, let's say we can given now the amount of rainfall, we can predict the umbrella cells. Okay, so like for example, if the rainfall amount is 80, okay, then it will be, what will be our y? Remember, y, it's our umbrella cells, so it will be 0.4 multiplied by that is 80, okay, minus what? -2. Okay, so this will go with this. Okay, so this will be is it 20, 32? This will be now 32 minus what? 2, which will be 30 umbrellas. So that is given this amount of rainfall, we can predict that we'll make cells of what? 30 umbrellas. Okay, but you can see this number can be inflated. Why? Because we don't have historical data. Okay, we don't have historical data for, that is for the umbrella cells given a certain amount of rainfall. Okay, so with that, but given now the historical data, then your prediction will be what? Will be more accurate. Okay, my prediction here might not be accurate because I don't have historical data. Okay, what does that mean? For you to make any prediction, okay, for you to make any prediction, you must have historical data with you. Okay, because now it's based on the historical data, when now we can get what? When now we can get the the future. Okay, the future prediction. Okay, yes. So that's just an overview of whatever we'll be dealing with. Okay, so we'll talk more. That is, we'll talk more about dependent variable. That is independent variable. We'll also talk about optimization of the model. How can we optimize our model to get better results? Okay, to get better results. And also we'll see maybe some factors or some assumptions which we have to make when now doing linear regression. Like for example, we usually assume that the two variable must have a linear relationship, or there must be a linear relationship for us now to perform the what? The regression analysis. Okay. The other thing we can say, maybe if you are dealing with more than two, let's say more than one independent variable to predict, that is a dependent variable, then there should be less or no multicollinearity. Okay, like the two variables should not be what? Correlated. Why? Because if the two variables which you are using to predict the outcome, if they have a strong correlation, then it will be very hard for you to know which variable, independent variable, it's impacting what? It's impacting your result. Okay, just a minute. I take a cup of water. Okay. Thank you. So basically, that's what we are going to do. Okay. So don't see it as complex. Okay. Don't see it as a complex thing. It's very easy. Okay. It's a very easy concept. So as we will be going through the notes, you'll see how easy it is. Okay. All right. Good. Now let's start from the introduction. I like doing an overview because once I give you an overview, like you already know what you are expecting. Okay, so you will be very keen to see if a specific concept I talked about, if it's now coming clearly to you. Okay, yes. All right, good. Now, what is that is regression, or what is linear regression? Okay, what is linear regression? So, linear regression analysis is used to predict the value of a variable based on the value of another variable. Okay, linear regression analysis is used to predict the value of a variable based on the value of another variable. The variable, basically, that's what we've discussed. Maybe just to that is elaborate. Okay, you can see that we are saying that linear regression analysis, first of all, it is used to predict what? The value of a variable. Okay, so in our case we said it's that is y is equals to mx plus c. Okay, so this is what we are trying to predict. Okay, why? It's our outcome, what we are trying to predict. Okay, then we are predicting it using another what? Variable x. Okay, so we are using x to predict what? Y. Why am I not talking about that is M and C? It's because M and C are just constants. Okay, they are just constants. So once we get the values of M and C, they won't change. Okay, they won't change unless we are optimizing those values. Okay, they won't change, but we can be changing what? Changing the X variable, okay, to check maybe the possible outcome. That's why we are saying that it is we use that is linear regression analysis is used to predict a variable based on the value of what? Of another variable. Okay, so the variable that you want to predict is called dependent variable. That is our y. Why? It's our dependent variable. Okay, it's our dependent variable, it's our explanatory variable. Okay, and also it is our outcome. Okay, or our output. This is our output. Okay, it's called dependent variable. Then the variable you are using to predict the other variable value is called independent variable. Now, our x here, it is the independent variable. Okay, we are using x to predict y. Okay, that's why we have another name for independent variable. We also call them that is predictor variables, okay, or predictor variable or predictor variables, because you will remember under linear regression we have simple linear regression, meaning we only have one that is one predictor variable, okay, and also we have multiple linear regression, meaning we have very many values of what, very many values of, that is very many predictor variable. Like for example, it can be y is equals to a that is a multiplied by that is x1 plus b x2, okay, plus what, plus c, okay, and also plus epsilon, okay, that is epsilon is what, epsilon it's a error term, okay, it is error term. So basically what I'm trying to mean here is, you can see in this case we are having what, we are having two that is independent variables, okay, so these two independent variables will be used to do what, to predict the what, the outcome here, okay. Yes, good, let's continue. Let's continue. So this form of analysis estimates the coefficients of the linear equation, okay, estimates the coefficients. This form estimates the coefficients of the linear equation. What are our coefficients? Now our constants are our coefficients. That is A and B. A and B are our constants, coefficients or constants. Okay? Yes. So, involving one or more independent variables, the best predicts the value of the dependent variable. Basically, what we are saying that the analysis tries to estimate also coefficients of a linear regression involving one or more independent variables. So we can have one or more independent variable. Okay, that best predicts the value of the dependent variable. So linear regression fits a straight line or surface that minimizes the discrepancies between the predicted and the actual output values. Okay, so we know that there are simple linear regression calculators that can be used that use the least squares method, okay, to discover the best fit line for a set of paired data. But we'll just talk about this in deep when that is discussing or when we'll be looking into details about what, about that is about the regression, okay. All right, so you can estimate the value of x, that is dependent variable, sorry, here we must have a problem here. You can then you then estimate the value of x, this should be the other way around, okay, because x is the independent variable, y is the dependent variable. So just ignore this uh, point, okay. Let me just remove that point so that it might not bring confusion to you. Good. Now, as I had that is shown you the linear regression. Remember us that is drawing or presenting the data in what? In a linear or in a linear format, or by using a straight regression line. Okay, good. So you can see that we are saying that linear regression performs the task to predict a dependent variable value y, okay, based on a given independent variable. Linear regression performs the task to predict, of course, dependent variable, which is our y, given independent variable what? X. So this technique tries to find out a linear relationship between what? Between X, which is our inputs, and Y, which is our what? Is our output. Hence the name linear regression. Why? Because we are having a linear that is relationship between what? Between that is the two variables. Okay? All right. So in the figure above, that is X input, is the work experience, and Y output. Like for example, in this that is figure above, we can say that X, of course, is our input. So in this case, it can be work experience. Okay, if we are trying to predict the salary of someone, remember yesterday I gave also an example of the salary model. Let's say assume we have the salary, okay, is given by, let's say, A or theta, let's say theta 1. This is basically to show what? To show a constant, multiply by x, okay, where x is now our work experience in years, okay, plus that is theta 0, which is now our second what? Our second intercept. Okay, so here we can say in the figure above, x, which is the input, is the work experience, and y, the output, is the what? Is the salary of a person. So the regression, that is the regression line, is the best fit line of our model. So this regression. So let's assume now you are given these data points. You can see we have different data points here. Okay, very many different that is data points. So doing regression, we'll try to find the best fit line, okay, or the best line which will fit most of the what? Most of these data points. Okay, so the that is the line which will best fit, okay, most of the points, okay, that is which are in the what? On the graph. So that's why you can see maybe we have some points which are on, which are not on the what? On the straight, on the that is on our straight line. Why? Because we plotted a line of best fit, okay, to cut the most of what? Most of the data points in linear manner. Okay, so meaning if we extrapolate this line, okay, if we extrapolate this line, it will cut the y-axis at this point. Let's say point that is point C. Okay, so this point will be now our y-intercept. Okay, or it will be our theta 0 in this case. Okay, and then you can now try to select two points which are along that is are along the what? The 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 equation, that is the line, the regression line, okay, and make sure you make a right triangle that is with 90 degrees, okay. So for you now to get the that is this point and this point, okay, and get it as what? Change in x, and then along the y-axis you'll get this point, okay, and this point, okay, to get your what? Change in what? Change in y. to get your change in y. So if you get now that is the slope or the area of this right angle, then you will get what we call slope, or our what? Our x, that is our x coefficient. Okay, our x coefficient, or the coefficient attached to what? To x variable. Okay, any question by they up to that point? Any question up to that point? Are we good? Are we all good? If we are good, by show of thumbs. Susan, we are good. Adore, we are good. Seems Adore is happy. Deborah, we are good. Steve, Wangui, we are good. What about David? I've not seen your thumb. With also Rose and Frederick. David, are we together? Or maybe we lost you somewhere. David, are we together in this? Okay, seems we are not with David. What about you, Ross? We are good? Are we moving together? Okay, maybe they are busy cooking. All right, let's just continue. So let's now continue. So definitely whatever we've said here, it's whatever I've explained up here. Okay? Yes, so that is we have x, which is the input data. We have y, which our what? Which is our output. Okay? Yes, and then we have our y-intercept and our what? Coefficient of what? Of coefficient of x, or the slope. Basically, this is what it's the summary we are getting here. Good. Let's go to type of linear regression. So, linear regression can be further divided into two algorithm, or into two types. We have simple linear regression. I had already talked about this, and also multiple linear regression. So for simple linear regression is like this one, that is mx plus c. We only have one independent variable. If we have one independent variable, then we are talking about simple linear regression. If we having, let's say, y is equals to a x1 plus b x2, okay, plus c, then you can see we have more than one, or we have two that is independent variables. Okay, we have two independent variables. So in this case, this will be what? Multiple linear regression. Okay, so simple linear regression, if a single independent variable is used to predict the value of the numerical dependent variable, then such a linear regression algorithm is what? Is called simple linear regression. Why? Because we are having one independent variable. Okay? Then, for multiple linear regression, if more than one independent variable is used to predict the value of a numerical dependent variable, then such a regression, linear regression, is known as multiple linear regression. Okay, good. Now, what about the regression line? Remember, the regression line is like the line of best fit. Okay, so we can have two lines of best fit, which is showing a positive linear relationship, and another one showing negative linear relationship. Okay, so a line or a linear line showing the relationship between the dependent and the independent variable is called a regression line. A regression line can show two types of what? Two types of relationship. Either a positive relationship or a negative relationship. Okay, let me just give you the examples. So we have this and we have this. Okay, so for a positive, that is for a positive relationship, linear relationship, you will find that as the value of y is increasing, so does the value of what? So does the value of x. When y is increasing, x is also increasing. When x is increasing, so does the y. Okay, y is also increasing. All right, good. What about now this one? Now in this case, when that is when the y is increasing, you'll find that x is what? Decreasing. All right, as that is as x is increasing, while that is y is what? Y is decreasing. Okay, yes, so now that shows the what? The negative relationship. Okay, all right, so let's start with that is the positive. So for positive linear regression, if the dependent variable increases on the y-axis, okay, and independent variable increases on x-axis, then such a relationship is termed as what? Positive linear relationship. Okay, then negative linear relationship. If the dependent variable decreases on the y-axis and independent variable is increasing on the x-axis, then the such relationship is called a negative linear relationship. Okay, so you can see as one is increasing, the other one is what? Decreasing. All right, so with that we have a negative linear relationship. Good, I guess we are good up to that point. Okay, then I want to just describe this subtopic, that is finding the best fit line, and then I will end my today's class at that point. So that now on Monday we can now discuss about that is the cost function, which whereby the cost function tries to that is to find the best coefficients. Okay, then we'll talk also about gradient descent. Okay, model performance. Okay, and then we'll finish with what? The assumptions of linear regression, and then we'll go to the practicals, because it is under practicals where now we'll get the idea in a better way. Okay, all right, so when working with linear regression, our main goal is to find the best fit line. That means the error between the predicted values and the actual value should be what? Minimized. That is the distance between you can see these values, that is this value and the what? And the line of regression. Okay, that distance should be minimized, because the smaller it is means the standard error is what? Is very minimal. And when the standard error is small or is minimal, then it means our model will perform well. Okay, or we have high accuracy in what? In our model. But maybe imagine if we had some points here, other points here, 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 and the regression line is still here. So you can see we have a very huge, that is standard error, okay, value. So you'll know that the larger that is the standard error, okay, the larger the error, the what, the poor your model is, okay. Right. So the different values for weights, all the coefficients of line gives a different, that is a different line of regression. So we need to calculate the best values of what? Of the constants. Okay, that is the constant A0 and A1. Okay, so that we might get that is the best fit of line. Okay, and how do we achieve that? To achieve that, we usually now use what we call cost function. Okay, we usually now use the cost function. So in our next topic now we'll start discussing about what? About our cost function. How we can optimize our what? How we can optimize our constants. Okay? Alright. Otherwise, that's all for today's class. Unless maybe you have questions.